Hello and welcome to an Unreal Engine 4 tutorial. My name is Saragan and today we are going to be looking at ray tracing. Now this is for players to use to sort of give like a line trace from where the player is to what they're looking at, so you can do interactions with actors, or to be honest, whatever you get what you're looking at effectively. So we're going to be doing this in C++. You can do it in Blueprints. However, I prefer to do this in C++ only because that overall is just makes things a lot faster. And given that this event sort of uses the event tick, yeah, I would rather it be in the C++ side than the Blueprint side, because obviously you really shouldn't put that much on event tick. But on top of that, you can always create a Boolean flag or something that just basically turns it on and off, so you can save yourself some time. Now, this is just a standard first-person template. We've got physics actors, and I think these ones are just static actors in here. So we will probably be using specific channels. And if I go to project settings and collision, yeah, channels, you can do your own. I can show you how to do your own. C++ is a bit weird because when you add your own for an object channel or even a trace channel, you have to define it in C++ as a defined bit of code, so a defined like variable. I will show you how to do that. In fact, I will just add one placeable. Just so you can see how that works. So we've got a channel here for placeable. Now let's go to actor component. So we're creating a new C++ class, actor component. I always create this as an actor component just so it sits with the pawn that you are currently spawned in as. And you can add it to any actor after the fact, so it just makes it a little bit more reusable. And I'm just going to call this ray trace. You can call it ray trace component if you want. I'm just sticking it in the main project because I don't have any plugins in this this project, so let's get that added in. Reload all. And we have our ray trace. Now this one's a fairly simple class. You've got your standard generate body, you've got your constructor, begin play, and tick. I will be doing the tick attachment and event handling in Blueprints. You can do that in the character tick component, which is in here somewhere, if it's even added. No, they haven't added it in here. They've got begin play, but that's about it. I don't see a tick event. No. Okay, so yeah, I'll probably just add it in the Blueprints for the time being. As I said, you can move them around. Now what I will do is I'm going to copy and paste the code from my other project I've got on my other screen, only because that saves you having to sit through all the typing, and then you can just pause the video once each bit has gone in. So first thing I do is I want to declare a delegate parameter for the returned hit result. So when you look at something and it finds an actor, you want to return the hit result that that actor has hit. I mean, I can't really say it any any better than that. This will define a little bit later on. If you are going to define a placeable object channel, sorry, a trace channel, you have to define it sort of like this, and you define what you want to call it, and then you set it to equal one of the channels. Now there is, I think, 1 to 10, is it? I think you can have up to 10 I can't remember exactly, but yeah, you can define it like that. I'll leave that there just for the time being. Next, we need a blueprint callable function, which I'm going to add to the public side down here, and we're just going to call getInteract. You can call this function whatever you want. This is what the tick component will call. I'm going to leave it under the category for ray trace. It really is a line trace, I suppose, less of a ray trace. And I create a separate C++ function for GetTracedActor, and this is the one that will do all the heavy lifting and return. Yeah, go away, thank you. Return a hit result, which we then in turn will return through our delegate. We need to include our tracing character, which we need to put above the generated. So I will type this one out because it's different on my other project. And we want tracing and tracing character.h. The autocomplete is, oh, there it is. Finally got there once I finished typing. And that means we need to take a tracing character, my character. Now, with doing this, we are storing a reference to our character, which we will do on begin play, and that just saves us having to do that in every tick event because excuse me, there's it can get expensive if you have to do that every frame. Next, we're going to need a property. Now, I found that was a little too big, but effectively this is how long or how far in front of the character we want to do a hit test on. And then finally, we have our delegate. Now that is what we defined up here. And when we define that in blueprints, because this is a blueprint assignable, when we define that, that's going to give us a node that will return a hit result called hit. So if you want to know more about how delegates work, just let me know, and I'll do a video on that as well. So that is it, I believe, in this class. We now need to do this one. And the first thing we are going to do is actually give us some includes. We need the Kismet system library. We need the same. Actually, what I will do is I'm going to take that one and stick it in here, and then I will forward declare this just to reduce the amount that we have to do. We also need the camera component. Just trying to think if there's anything else we need. I've got a lot in mind already. No, I think that is it. So on begin play, we have my character, and that is going to equal a cast of a tracing character, and we want get owner. Okay. Now this is obviously going to match whatever character class that you have. My suggestion is I tend to always create a base class for character that comes from this one. Leave the stock one alone. I always create a base character class, and then I subclass further down from there. Right, we need... Do I have it installed? That is a good question. That's not really helpful. No, it's not going to play. Right, I will have to copy and paste this. That's fine. Because I think it's the same. Yeah, it's the same. That's fine. So this getInteract, this is the one that the blueprint is going to call. As I said, you can name it whatever you like, but this is then going to call GetTracedActor, which is our generic function that we're using. I created this as generic. It's because if you want to use it in other parts of C++ or other classes, then at least it's separate from the blueprint one. And if we get a hit result, we're going to then broadcast our hit result on our delegate that we created here. So yes, it's a very straightforward function. And now we've got to the slightly more complicated function. Only slightly. So we have our GetTracedActor. We're finally implementing our main one. This returns type hit result, so we've got to return type hit result. So that's the first thing that we want to do. Now with tracing, certainly for the first person, I usually use the gun's location and then try and add a forward vector from the camera's perspective to give roughly where that reticule or the center marker is. So what I usually do is I get the character's gun and get the component's location. Now, if you look on the character, you do have this gun. It is a skeletal mesh and it is set to a specific location. On the player, I think it's actually bound to a socket, if I remember rightly. Where's the beginning here? Now it's finding the things. We need setup attachment, root component. I thought it was bound to a socket, but maybe not. Maybe they just position it. Okay, fine, whichever. But either way, we get the gun's location because when you're firing, that's sort of what you're firing from. If you're doing third person, I actually found that the characters, if you get the head part of your mesh and use that works very well for third person. So second, we need to get our forward vector. Now the forward vector is getting our first person camera component and then getting the forward vector. So we're getting what are we looking at and then getting our forward vector. Remembering the forward vectors have direction and magnitude. So we are going to add to that magnitude and get the forward vector. We're going to times it by 1,000 to increase that distance, and then we're going to add it to the start point. So we got our start point in the direction of that forward vector with 1,000 units forward. So we now have our start and our end. I think this will go away. Oh yes, the first person camera component, I think also the gun are private in here. You can move these down into specific public. I'm just going to move a public up there just to save time, and then that will get rid of those errors for you. So just keep that in mind that these will be private. You could probably go, can you go protected on that? You might be able to go protected on that. Right, so we now need to create our hit result. And this is our out hit. So when we call our line trace, the results will be stored in this variable. And in the end, this is sort of what we're going to be returning as part of our function, which will then end up in our delegate. So what we need here is to set some parameters. Now this is collision query parameters. This will give you the tags, whether you are doing it complex, and the owner of that trace. Is it really important? Am I even using that now? Actually, that is a good question. You know what? I don't think I'm even using that anymore. Scrap that. I'll see if it works without. Let's go on to the next thing. Trace object types. Now this is where your channels come into play. I'm just going to copy some in here just so you can see what we're doing. So this is an array of effectively enum as bytes for object type queries, and this is adding world static, dynamic, and pawn. One we need to add to this, just for this purpose of this demo, is the physics body. Now those physics bodies are those cubes, because if you highlight a cube here and you go down to collision, see it's set to physics actor. If I expand that, you can see object type is physics body. So yes, you need anything that you want to actually have hittable and return the hit results. You need to make sure you include that into your tracing. Why are you complaining? Yeah, it'll sort itself out. The other thing that I tend to do is add an ignore. So this is an array of actors that you specifically want to ignore. Now, you don't want the trace to stop at you. So if your animations are a little bit more wild and they get in the way of the trace line, you don't want to have that affect your trace, because that would just annoy you. So I always add myself or the owner as an ignore, so it can just exclude it from all trace results. Finally, one of the important bits is this line. Now what this does is it uses the Kismet system library for line trace for single objects. It takes a world parameter, a start vector, an end vector, which we calculated earlier, the traceable object types, which we have defined as static, dynamic pawn, and physics body. We don't want a complex trace, so if you make it complex, it's more heavy. This is just a straight line trace. And we've got the actors to ignore, which is this, and the debug trace for one frame. Now there are multiple options for this, but you can have it like set to none, which is fine. But for debugging purposes, I like to see where the trace line is and what it is hitting in the editor and in real, while you're playing the game, just so you can understand, what actor you're getting back. Here is the out result. So this is the out hit. So this will be using effectively a reference to this object here. And then finally we have our ignore self. Now I don't know whether ignore self does the same as what we've done with the ignore get owner. I am not too sure on that, but I would still add that there and ignore self anyway, just because it makes more sense. Now, last bit for this function, I'm just going to copy in. We are checking whether we have a result. I can probably just, I don't know why I sub if this. Let's just put that in there and get rid of that. Probably cleaner ways of doing that, and I could probably put it in a single line here. Yeah, I'll do that. Let's get this in here. Just clean up my own code, ladies and gentlemen. Don't mind me. Right, so if we have a result and the out hit B blocking hit is true, which means we have hit an actor, then we return out hit. Otherwise, we just return a standard hit result. Now, this is going to be the same sort of logic that we have up here. But the difference is we're returning an empty hit result, or we're returning that. Whereas up here, we only really want to fire off this delegate if we are actually hitting the block, hitting an actor. So yeah, that is pretty much it for the ray trace class. We now need to add it to our character. Now, I am going to our trace character here, and I'm just going to give ourselves a little bit more space and put in here a U property. I don't know why I've got blueprint, read only, and edit anywhere. No, I think that's fine. Category trace meta, allow private access. That just means that you get access to private variables. There aren't really any in here, so that's kind of irrelevant really, but I always enable that for my components, only because it just exposes a little bit more functionality overall, and we don't lock it down like Unreal Engine do with some of their classes. We forward declare our utrace class, which is the one we just created, and that is all we need in this one. And we need to go to our CPP. And we'll come down here, give ourselves a little bit more space. And then we actually need to create the default sub-object of uTrace type trace. We will need to include our can't spell today, tracing / ray no, come on, don't make me type it out. Whatever. We include that header library at the top for the one we created, and because we forward declared it here, so we need to include it, and then include our creation here. Now, in theory, providing I haven't done this wrong. Hey, built first time. How nice. We can come back into our editor now, and you'll see nothing's happening because we haven't actually tied it in. So if we go to our first person blueprint, first person character, let's pin that. Oh, forgot about that. You can see now we have our trace component here. You can't see anything in here because it does nothing. We have no code in here, so what we need to do is add the event tick. We need to grab our trace component, and we need to call that GetInteract. Okay, so now that will fire off and do our GetInteract. We also need to register our delegate method, and you can do that if you go to your trace component, right click, add event, add on hit delegate, and you can see that now returns a hit result. Now you can either choose from there to break hit result, or you can split struct pin right here, and that gives you all your hit result information. Now if I go and print string for this and put in our hit actor, then that should be it. Now if we play, see we've got our floor, but it stops there because we're slightly too far away. You can see we now got edit to cube, big wall, edit to cube, 13, 14, 10, 9, 8, big wall, floor. So yeah, that is effectively it. So now you can do whatever you've hit. You can now like work out the hit location. You can store the hit location. You can potentially spawn items like walls and things, and at least that way it gives you a nice clean way to do it. If you're doing building, for example, you can probably add a new variable for is building. Grab that in there. You can then insert a branch by hitting the B key and clicking in your editor, and if building, then that locks it down so it's not running this every tick. But obviously if you're doing a game where you look down and you can actually pick up objects, you probably want this enabled permanently. But what you probably want to do is down here is check the type of actor that you have actually hit, and then maybe create an interface to say, you know, is this interactable or something along those lines. But yes, that is it. I hope that has helped somebody. And yes, if you want to see more tutorials, feel free to leave comments down below. Feel free to like and subscribe to my channel. This is a fairly newish channel. I do have a gaming channel. If you can search YouTube for Saragan, it's a very similar icon. If you like to watch people play games, then I do an awful lot of that. And yes, that will be all. So thank you very much for watching. Bye for now. Bye bye.